This is the Introduction to Networks. Today our outline is going to be, we'll go over some different examples of networks. We'll look at some different problems that you can solve with networks. We'll talk about some basic questions. We'll go over terminology, and then we'll open up our Jupyter notebooks and play with it a little bit with Python. So who can tell me a little bit about any ideas you have for what a type of network would be? Yep, social media, that's the one that usually comes to mind first. What else? Okay, yeah, those are all good ones. Some others I thought of are organizations, whether that's your neighborhood, your city, a country, a community, a government, maybe a terrorist organization or a corporation. Transportation networks like rail lines or roads or airplane networks, flight networks. Some diseases or information. Does anyone know why we might put those two things together? Yeah, it's because they're both things that we'll measure the spread of, and they go between people generally. So whether it's biological or if it's sociological, so information's between groups. And then another one is citations, and those become important because to track back where did you get the information from originally, and because they're generally what we call directed, which means they go one direction. And then obviously the internet. And do you guys remember the difference between the World Wide Web and the actual internet? Yeah, it's because of the World Wide Web is the actual software, the websites, the pages, and internet's the actual hardware, the hubs and routers and things. So some problems that we can look at with networks is we can analyze communities, we can detect fraud and risk. Like I was mentioning about the disease or information, we can either model it or even predict it. And of course, for social networks or terrorist networks or government conspiracies, we can always find the most important influencers. Now, the types of questions we'll typically ask of networks are how big is it, who's connected with who's the most popular, who's in which groups, and we'll even be able to detect groups that may not be already labeled as an attribute. And what is the fastest way across the network? Obviously, you think of that when we talk about maps, but there's other ways. So if you're on your LinkedIn and you want to know who the closest person to you to maybe the hiring manager that you're trying to get in touch with, you can find that. Now, some terms we're going to look at. There's a couple ways to talk about this. We're going to call it network analysis, but it's just as easily called network science or graph analysis. Network science is kind of the social science background for graph analysis. Graph analysis is where it started in math. And so we have terms like network from network science and graph from graph theory. And then network science is on the left here, the left side, the nodes and the links, where in graph theory they talk about vertices and edges. There's an asterisk by edges because when we're doing our programming in Python or whichever, links typically refer to your path links or maybe your API or your website links. So a lot of times, even though we're talking about links, you'll still see them called edges. But just realize that each of these three terms you can use them interchangeably. Now neighbor, this is the same sense as if you recall our k-nearest neighbor lesson. Neighbors are just the nodes that you're connected to. So if you have a link between you, then it's a neighbor. Now counting up all the neighbors that you have are the degree. And then counting up all of the degrees that all of the nodes have is the distribution of the degrees. So you can look at the entire network and say how many connections do all the nodes have, and you can put it on a histogram. We'll do that in a little bit. And then if you want to normalize that so that it becomes a percentage or a 0 to 1, then you're just looking at something we can normalize for every one of them. Because if you have a network with a node of 10,000 links, then having 1,000 links may not be a lot compared to a much smaller network. So we do look at the normalization of that, and we call it degree centrality. And then, of course, the fun one that everyone wants to do is the shortest path. So how do you get to the other side the quickest? So we're going to go ahead and open up your Jupyter notebooks, and we will get started with some coding.